Okay, let's just start the session. It's 7:40. Okay, so next topic is the reaction with carboxylic acid. Okay, so basically we were discussing the reaction of alcohols with different reagents, right? So second reaction is the reaction with carboxylic acid. Yeah. So alcohols, when react with carboxylic acid in the presence of concentrated H2SO4, okay, or dry HCl, or you can also take concentrated H2SO4 or dry HCl to form an ester. So what happens? What is the use of this concentrated H2SO4? So concentrated H2SO4 is a dehydrating agent. Basically ये क्या करता है? ये just dehydration करा देता है, right? So it's a concentrated H2SO4 is a dehydrating agent. Okay. You see the general reaction. RCOOH, this is a carboxylic acid, right? And when you react the carboxylic acid with the alcohol, so this is your R-OH and this RCOH. So what happens? And when you are using this reagent, क्या use कर रहे हो? Concentrated H2SO4. So the concentrated H2SO4 is a dehydrating agent. So what you are supposed to do in this reaction? Just remove the water. Dehydration करा देना है. And this is the carboxylic acid RCOOH. So OH, this group, H from the carboxylic acid, and OH group from the alcohol. OH group from the alcohol. So this will combine, this will just sorry, just a second. Just a second. The OH group, yeah, say this reaction again. So RCOOH plus this is your R-OH. So this is your alcohol and this is your carboxylic acid. What you are supposed to do, this OH group, hydroxyl group from the carboxylic acid and H group, H आपने किससे remove कराना है? From the alcohol. So these two combines and they form water. Okay, so in the presence of a concentrated H2SO4, when alcohols are treated with carboxylic acid, then dehydration occur. Okay, means OH group from the carboxylic acid and H group, H atom from the alcohol, they combine together and they just dehydrate. Okay, they just remove as a water, and this RCO, it will combine with OR dash. So you will get this ester. Basically, you will get ester. Got my point, Muniba and Safrina?
Yes, ma'am.
Okay, so it's very easy. What you're supposed to do, this OH group from the carboxylic acid and H group from the alcohol. So they just remove as a water, and ये क्या करेंगे? ये combine कर लेंगे this CO with OR dash and you will get ester. Okay, now see the examples. So example is CCH3CH2 COOH when it combines with methanol. Then tell me what will be the product. Yes, Muniba, what will be the product here?
Um, in place of COOH, it becomes CO double bond O and CH3.
Okay, good. What you're supposed to do, this OH group from the carboxylic acid and H group from the alcohol. Okay, they just combine together and they just removed as a water. And what you're supposed to do, this CH3, CH2, this CO group is from the carboxylic acid, and this CH3O group will be joined here from the alcohol, this OCH3. So this will be COO group, means this is the ester. Okay, so ester will be formed. Okay, so the mechanism is very simple. What you're supposed to do, this OH group from the carboxylic acid and this H group from the alcohol. Okay, just remove kara do as a water, and this will group this CH3, CH2, 3 carbon chain. Sorry, 1, 2, 3, 4, 4 carbon chain. And here O group is present. And this 1, 2, 3. Okay, so this will be attachment will be there from negative part because this carbon is a positively charged, right? Carbon is a positively charged, and this negative part of oxygen will come and attach this oxygen, attach this carbon and 1, 2, 2 carbon. Fine. This will be the product. Next one. So can you please tell me the name of this product? What will be the name of this product? COO, this is your ester, right? And this is your ethyl group. Here, this is your ethyl group. Ethyl group is present. And what is this group? This whole group 1, 2, 3, 4, 4 carbon chain. So it will be known as butane. Okay, and ester के लिए हम क्या use करते हैं? OH. Okay, so the name of this will be butanoate, ethyl butanoate. This is the ethyl group. So ethyl butanoate. That is the IUPAC name of this structure. So here, see, you can see what is a esterification reaction. A esterification reaction, you have already learned this reaction in the previous class, like your 9th, 10th standard, right? So esterification reaction is those reaction in which the carboxylic acid are treated with the alcohols, right? When alcohols combine with the carboxylic acid, they form ester. And this reaction is known as esterification reaction, right? So this reaction is also known as esterification reaction. Why? Because here the formation of ester is being formed from the combination of carboxylic acid and the alcohol, right? So that's why it is known as esterification reaction. Got my point?
Yes, ma'am.
Now see, the presence of bulky group on either alcohol or the carboxylic acid reduces the rate of esterification reaction. It means the reaction, this reaction, esterification reaction will be very slow in tertiary than your secondary than your primary. प्राइमरी में सबसे ज्यादा फास्ट होगा. Why it is very, the rate of reaction is fast in primary alcohol or primary carboxylic acid? Because there is only one bulky group. Okay, only less bulky group is present, okay, either on the alcohol or carboxylic acid, and due to the less bulky group, there will be less hindrance, and the rate of reaction in the primary will be as fast as compared to the secondary or tertiary, right? Because you can see in secondary, like tertiary, this is a CH3 group, CH3 group, CH3. Suppose this is a tertiary alcohol, right? So carboxylic acid is attached to this carbon, and there are three alkyl groups, three bulky groups. So due to three bulky group, there will be a more steric hindrance. There will be more hindrance. Due to that, the rate of reaction will be very slow. Okay, so that's why the presence of bulky group on either like alcohol or any carboxylic acid पे भी हो सकता है और alcohol में भी. So if more the alkyl group is present, more bulky group is present, then the rate of reaction will be slow. It reduces the rate of esterification reaction. Clear? So
Yes,
what
ma'am.
will be the, so for alcohol, see, for alcohol, the rate of reaction will be fast in methanol. After methanol, it will be in primary, secondary, and tertiary alcohol. Tertiary में सबसे slow होगी rate of reaction. Why? Because there is a more alkyl group, more bulky group is present, and due to the more bulky group, there will be more hindrance, and the rate of reaction will be slow. For the carboxylic acid, what will be the rate of reaction? So it will be in formic acid, HCOOH. इसमें सबसे fast होगी, right? Because here no bulky group is present, no bulky group, no alkyl group is present, right? In the second में RCH2COOH. Okay, means the primary, then your secondary carboxylic acid, then your tertiary. So this is the rate of reaction, esterification reaction. Now see, phenols also show similar reaction with the carboxylic acid. Just like alcohol, phenols also show similar reaction with the carboxylic acid. So again, the phenol, see this is your phenol. Phenol, when it reacts with the carboxylic acid, what happens? When it reacts with the carboxylic acid in the presence of either dry HCl or concentrated H2SO. Again, you will follow the same mechanism. OH from the carboxylic acid and H from the phenol. They will combine and they just form water. Okay, they just removed out and you will get RCO. Okay, this CO. So from the oxygen of the benzene ring or oxygen of this phenol will get attached to this carbon. Okay, and you will get this is structure. So what is this? This is your phenyl alkanoate. Alkanoate. Right. So this structure is a phenyl alkanoate. Got my point?
Yes.
And can you scroll a bit up?
Yeah, sure. This one?
Yes, ma'am. Okay, ma'am. Thank you.
Okay, next one is your the reaction with acid chloride and acid anhydride. Acid chloride and acid anhydride. Now, what is acid chloride? So, acid chloride is RCOCl. RCOCl is your acid chloride, or you can also call it as a acyl chloride. इसे हम क्या कहते हैं? Acyl chloride or acid chloride. And what is acid anhydride? Acid anhydride or acyl group you can call it as. So this is your R C double O C O R. This group is known as acidic anhydride. Okay, so this is the anhydride group R. Okay, and here COO group, and this O group is further attached to CO and this R. Okay, this is the acid anhydride. Acid anhydride. So we will see the reaction of alcohol with acid chloride and the acid anhydride. So basically, this reaction occurs in the basic medium. We just take pyridine as a catalyst over here. And what is the structure of pyridine? This is the structure. Okay, this is the structure of pyridine. So CH3C2 COCl, which is an acid chloride. This is a acyl chloride or acid chloride, you can write, plus your methanol CH3OH. CH3OH. So when you take these, when you react this methanol with acid chloride, what happens in the presence of a pyridine? So in this reaction, what you are supposed to do, you have to eliminate HCl. You have to eliminate what? HCl. So from this acid chloride, you have to eliminate this chlorine, and from the alcohol, you have to eliminate this hydrogen. Okay, so you have to. So when you react the alcohol with acid chloride, you have to eliminate the HCl. Okay, hydrogen will be removed from the alcohol, given alcohol, and the chlorine group will be removed from the acid chloride. Okay, so HCl plus this will be CH3CO, and this oxygen will get attached to this carbon OCH. Again, your ester will be formed in this case also, right? So that's the product. Is it clear?
Yes, ma'am.
Yubita and Safina?
Yes, ma'am.
Yes, ma'am.
Okay. Okay, Safina, then tell me what is the product in the second question? CH3CO, Cl when it reacts with your ethanol. So what will be the product here?
CH3CO,
CO, yeah.
CH3CH2.
Okay. No, ऑक्सीजन की तरफ
So,
से attachment होगी. See, what you're
yeah,
supposed to do, chlorine,
OCH3CH2.
yeah, yeah. So the chlorine from acid chloride and hydrogen from the alcohol. It will be combined and it will remove as a HCl. And CH3CO and attachment will be because see this carbon is electropositive, right? When this carbon and oxygen, this bond, this carbon is positive and this will have the negative charge, right? and this oxygen will have the negative charge, right? Because it's more electronegative than carbon. So obviously the negative will get attached to the opposite charges, right? Positive one. So you will get the oxygen will come and attach to this carbon and CH2, CH3. So that's the product. Yeah. Okay. Third one. Yes, Jupiter, tell me the third answer. Jupiter, third answer. No. Okay, Muniba, tell me the third one.
CH3, C double bond O,
Mhm. After that,
then O, and
then
CH2,
O.
CH2, CH3.
Yes, very good. Plus HCl. Right, so that's the product. Now that was the reaction of alcohol with the acid chloride. Okay, RCOCl. But what about the acidic anhydride? Means CH3, COO, COCH3. This is the acidic anhydride, right? So acidic anhydride के साथ when you react the alcohol with CH3OH, suppose we just take the methanol. Okay, so what you are supposed to do, this has this oxygen, this methanol has this lone pair, oxygen has a lone pair, right? So this and between this carbon and oxygen bond, which one will have the negative, partial negative charge? Carbon. Carbon will acquire partial negative charge because this is less electronegative than oxygen, and oxygen will get electro negative charge. Sorry, positive mean negative because this is oxygen is more electronegative than the carbon, so it will acquire partial negative charge. I don't know why this is not working. Yeah, partial negative charge and this carbon will acquire partial positive charge. So what happens? This oxygen has a lone pair, right? So oxygen, this lone pair will approach this carbon, this positive carbon. Okay, and again this hydrogen, because again between this bond oxygen and hydrogen bond, the hydrogen is more electropositive, right? And the oxygen is more electronegative, you can say. So this will acquire negative charge and this hydrogen will acquire partial positive charge, right? So again this oxygen will approach this hydrogen. Okay, because oxygen ye kya hai? This is a lone pair. Lone pair is nothing but an electron. Okay, unbonded electron. Electron is negatively charged, and so it will try to approach the positive one, which is the hydrogen. Hydrogen is electropositive, so this lone pair of the oxygen, it will approach this hydrogen and it will make bond with this. Okay, so what happens? You have to break this bond from here, and here two compounds are formed, CH3CO. See this. What happens? This bond will be break, and this these two compounds are formed. See, from here you will break the bond. This compound will be formed, and this hydrogen will goes with this one. These two things will be formed. Now you are. It's very easy to write down the product. CH3. This CH3, CO, and this CO, this carbon gets attached to this OCH3. So after that you will write OCH3. Okay, plus this one CH3 COOH, CH3 COOH. So in this, by the when alcohol reacts with the acidic anhydride, so it forms a mixture of ester and carboxylic acid, right? So here you will get the ester as well as the carboxylic acid. So how you will break the bond? See this COO bond. So अपने यहाँ से break कराना this bond, CO bond, this CO bond. Either you can also just bond this bond can be also break like CO bond, or either this. Okay, from both the cleavage you will get the same thing. Okay, so this O, basically you have to remember this trick or mechanism. Like this oxygen has a lone pair. This is negatively charged, so it will approach the positive electropositive element or atom of the other molecule, and this oxygen will try to approach the other hydrogen which is positive. Okay, so bond will be break from here, and this hydrogen will goes with this oxygen and it will form carboxylic acid, and this carbon will goes with this oxygen and it will form ester. So that's how you just get the mixture of ester as well as the carboxylic acid. Any doubt in this?
Mm.
Jubita, why not responding?
Ma'am.
Is it clear?
Yes.
Okay, next thing. So remarks. So this reaction is also known as acetylation reaction. Acetylation reaction because you are using the acetyl group. Okay, either acetyl chloride or acetyl anhydride. So this reaction is known as acetylation as the reaction introduces acetyl group. Okay, this due to this reaction, it introduces acetyl group in alcohol, CH3CO group. The CH3CO group is known as acetyl group. Okay, that's why this reaction is known as acetylation. Okay, and why we use the pyridine? So pyridine is used to neutralize the acid which is formed during the reaction. Okay, and it leads the rightward shift in equilibrium. ओके ये तो बैकवर्ड शिफ्ट नहीं होने देता है इट दिस pyridine हम क्यों यूज करते हैं टू न्यूट्रलाइज द एसिड फॉर्म बिकॉज यू कैन सी carboxylic acid is being formed in this reaction. So to neutralize this acid we use pyridine, and this pyridine helps us to shift the reaction in the rightward direction, in the forward direction. Okay, and phenol show the similar reaction. Similar reaction will be with phenol. Okay, same reaction you will see. Okay, now the next thing. This is very important. See, so question acetylation. So phenol is shows similar reaction. So how you can show the phenol reaction with the acetylation? The acetylation of phenol. You can also write down the acetylation of phenol as a heading. And the acetylation of phenol leads to the formation of aspirin. Aspirin. Did you hear the name earlier? Aspirin.
Yes, ma'am.
Yeah. So it's a painkiller. Aspirin is a painkiller, right? So we can prepare aspirin by the acetylation of phenol. Okay, it's very interesting reaction, and this is again very important. Question कैसे आ सकता है? Like write down the equation which is involved in the acetylation of salicylic acid. Acetylation of salicylic acid. And other question, how you will convert salicylic acid to aspirin. Okay, and aspirin is also known as your ortho acetoxy benzoic acid. Ortho acetoxy benzoic acid. Yeah, so let's see the reaction. How you will do the acetylation of salicylic acid. Yeah. So basically, first step, see the first step. This is a phenol. Okay. In phenol, when you react it with aqueous sodium hydroxide, so what happens? So it will form a sodium phenoxide ion. Okay. यहाँ पे क्या hydrogen will be replaced. Hydrogen will be replaced by a sodium. Okay, sodium metal, and you will get the sodium phenoxide ion. Now in the second step, this is a sodium phenoxide. O minus Na plus. Okay, okay. Second step, when you treat it with carbon dioxide, when you put the carbon dioxide, so what happens? The carbon dioxide, this COO, this COO, okay, minus carbon dioxide minus, and here O Na plus, O minus Na plus. So this reaction happens. After that, when you give the H plus ion, means in the acidic condition, what happens? This CO, here COOH, okay, and here you will get Na will be removed and OH will be there. So this is your salicylic acid. This is your salicylic acid. That's how you can form the salicylic acid by the sodium phenoxide, or first you will start the reaction with the phenol. अब phenol में क्या डालना है? Aqueous sodium hydroxide. So what happens? The hydrogen, यहाँ से hydrogen will be replaced and the sodium will come in the place of hydrogen, right? So here first sodium phenoxide ion will be formed. After that when you put the carbon dioxide and H plus ion, you can also show this in the same step. Okay, so first step में क्या करना है, carbon dioxide, so it will attach on this position, okay, on the adjacent position of the OH group. After that, when you do the acidic in the acidic condition, acidification कराते हो आप, so here the COOH and OH, okay, so this is your salicylic acid. This is your salicylic acid. Now, when the question came in your exam, like how you will convert the phenol into salicylic acid, so you will write only this step, like from phenol till salicylic acid, right? So this two questions can come, like when you how you will do the acetylation of salicylic acid. So if they ask you the acetylation of salicylic acid, then you have to show this reaction also. Just a second. Let me explain it again. Let me rub this.
Ma'am, can you repeat which one?
Yeah, just a second. Let me explain it again. Step by step, then you will get to know what will be the reaction. Okay. Okay. Write equation involved in the acetylation of salicylic acid. Okay, and the second is how you will convert salicylic acid to aspirin. Okay, see though these two questions are very important, but first you have to start with the phenol. This is the phenol. Okay, so sometimes question can also come right down here, how you will convert phenol to your 2 hydroxy benzoic acid, 2 hydroxy hydroxy benzoic acid. So 2-hydroxybenzoic acid is nothing. It's a salicylic acid. This one. You can see this is your benzoic acid, right? COOH. Benzene pe COOH is attached, so it is a benzoic acid. And here, this is the first position and this is the second position. So how you will write down the name? 2-hydroxy. OH group is hydroxy, right? And this is whole thing is your benzoic acid, right? So if in your exam they just ask you convert phenol to 2-hydroxybenzoic acid, or they can also give you the salicylic acid, only salicylic acid. So you should know what is salicylic acid. Salicylic acid is 2-hydroxybenzoic acid, right? So you should start with this phenol first. So phenol may when you put the aqueous sodium hydroxide, what happens? The hydrogen will be replaced by the sodium. Okay, so this will form sodium phenoxide. Sodium phenoxide ion. Phenoxide ion. After that, when you add carbon dioxide and in the acidic condition, okay, in any acid like H2SO4, anything, so H plus ion up doge, so it will form the carboxylic your 2-hydroxy benzoic acid, and this 2-hydroxy benzoic acid is your salicylic acid, right? So first CO2, first step will be carbon dioxide up doge, so carbon dioxide will come and attach on this position, right? And after that, when you do the acidification, this hydrogen, they come and attach on this negative part of the oxidation. So that's how salicylic acid is formed. Okay, and salicylic acid, the name of salicylic acid is 2-hydroxy benzoic acid. Okay, this is your benzoic acid. Okay, but what about the acetylation of salicylic acid? Okay. If the first question, see the first question, write down the equation involved in the acetylation of salicylic acid. Just a second. Yeah.
Ma'am, what is it? 2-hydroxy?
2-hydroxybenzoic acid. that is benzoic. You can write the whole name. Otherwise, you will get confused. Okay, so Ba is benzoic acid. Benzoic acid is nothing. This is structure. Why my pen is not working? This is a benzene. Okay, and benzene पे if COOH is attached, so this whole thing is known as, this molecule is known as benzoic acid, right? And if I attach under this position, second position, so if you are naming this as a benzoic acid, so if you are you start the numbering from this carbon. This carbon is first where the carboxy OOH is attached. So this is the second carbon. On the second position, the hydroxyl group is attached, OH group. So that's why its name is 2-hydroxy benzoic. Got my point?
Yes.
Okay. Next step acetylation कराना आपने. Okay. Just do the acetylation of salicylic acid. So how you will do the acetylation? So acetylation में you will treat this 2-hydroxybenzoic acid, means salicylic acid, with the acetyl group, acetic anhydride, CH3, CO. But first you should know what is acetic anhydride. So COO, COCH3. That is your acetic anhydride. So you are doing the acetylation of benzoic acid, the salicylic acid, basically, right? And you are giving the H plus ion also. So once you give this acetyl group, what happens? This CH3 COO group, this CH3 COO group will come and attach on the position of the OH group. Okay, on the position of the OH group. This is your, so this is your COOH. Okay, so यहाँ पे क्या होगा? OH will be removed and CH3 COO group will be attached. So this is a carbon, right? So you have to attach this via negative electronegative element from oxygen side, not from the carbon side. So just attach this. So this is the oxygen. Okay, then your carbon, oxygen, and your CH. Okay, this is the acetyl group. So just attach the acetyl group, this acetoxy group, you can say. This is a COO. Okay, this is the ester group. So acetoxy group on the ortho position. This is the first. And when you compare this position, so this is the ortho. This is the ortho meta para, right? So on ortho position, you have to attach the acetyl. So this is your aspirin. What is this? This is your aspirin. And what is the IUPAC name of the aspirin? So it's a, बेसिकली एस्पिरिन को हम क्या कहते हैं? एसिटाइल, एसिटाइल सैलिसिलिक एसिड, एसिटाइल सैलिसिलिक एसिड. And the IUPAC name of this is ortho. You can write, this is the ortho position, right? So on ortho position, this is the acetoxy group. What is this? This is the acetoxy group. So ortho acetoxy benzoic acid as the IUPAC name of aspirin. So question can come like how you will convert the phenol to orthoacetoxybenzoic acid, or how you will convert the 2-hydroxybenzoic acid to orthoacetoxybenzoic acid. किसी तरह भी questions दे सकते हैं. Okay, either they can give the salicylic acid name. Okay, so you should know what is salicylic acid. 2-hydroxybenzoic acid is salicylic acid, and how you will convert the salicylic acid into aspirin, means orthoacetoxybenzoic acid. So you have to do nothing, just do the acetylation. Okay, add the acetylation, acetic anhydride to it, and add this part on the ortho position, the CH3 COO part on the ortho position. So this is your aspirin. Any step? Is there any doubt in any step? You can ask me, because this is very, very important, this reaction. Aniba, Safrina, Jubita, is it clear?
Yes, ma'am.
Yes, ma'am.
Yeah, so question can, these three or anything they can ask. Like they will ask direct question, or they can just give you the conversion type question, right? So how you will convert salicylic acid to aspirin? Like write the equation involving the acetylation of salicylic acid. So both have the same reaction and same mechanism. Questions कुछ भी पूछ सकते हैं, like anything. Okay, written.
Ma'am, can you scroll up?
Yeah, sure.
Okay, scroll down.
Please practice this mechanism by yourself. 2 to 3 times, 4 times, maximum times practice, then you will be mastering that.
Done, ma'am.
Okay. Okay. See the next reaction. So all these above reaction was a reaction which involves the cleavage of OH bond, oxygen and hydrogen bond of the alcohol. Now we will discuss the reaction which involves the cleavage of C carbon and oxygen bond, carbon and oxygen of the alcohol. Okay. Now see, because higher the polarity of COH bond, easier it is to break the bond. जितनी ज्यादा polarity होंगी means more the difference in the electronegativity, more easier it will be to break the bond, right? So higher the polarity of COH bond, easier it to break the bond. So as the number of alkyl group increases at alpha carbon. Now the question is, what is alpha carbon? So suppose this is your CH3, CH2, CH2, and sorry, this is CH3. So what is alpha carbon? So see, this OH group is attached to this carbon. OH group is attached to this carbon. So this is your alpha carbon. This is your alpha carbon. And after this adjacent, the carbon which is adjacent to the alpha carbon is your beta carbon. So there are three beta carbon here, beta 2 and beta 3, right? So I hope you know what is alpha carbon, right? So as the number of alkyl group increases at alpha carbon, the electron density around the oxygen atom increases, which makes the bond more polar and the carbocation formed is more stable, right? So what happens? What happens? जितने ज़्यादा alkyl group होंगे, see, OH group is attached to this carbon, so this is an alpha carbon, and more the alkyl group. See, there are three alkyl group here, which is attached to this alpha carbon. So more the alkyl group present, which is attached to the alpha carbon. So the electron density, what happens? This alkyl group का क्या काम होता है? It is a which group? Yes, it will show minus I effect, plus I effect, which effect? Hmm? Alkyl group, R group. So see, this alkyl group basically a electron donating group. And due to the electron donating group, plus I effect show करते हैं this R group. Plus I effect is basically it pushes the electron density towards the chain. See, so let me rub this. It's become messy. Let's see, this is your CH3, C, CH3, CH3, and OH. So OH is attached to this carbon, so this is your alpha carbon. So alpha to the alpha carbon, there are three alkyl group attached. Okay, three alkyl group is attached, and you know very well alkyl group is a electron donating group. And due to electron donating group shows plus I effect, plus inductive effect. And what does plus I group shows? Basically, inductive effect क्या होता है? तो this electron donating group, so this pushes the electron away from itself. खुद से दूर push करता है, like to the adjacent carbon. So this CH3 group will push the electron density towards this carbon. Okay. Again, this alkyl group, again it will show the plus I effect. It push the electron towards this, and again this. So what happens? What happens here? The carbon between the carbon and oxygen. I just told you, more the polarity, more will be the more will be more easier will be it to break this bond. Right. So here what happens? The carbon to the carbon, the electron density will be quite high. So electron density increases around the carbon, this bond, this carbon and oxygen. So overall किस side जा रहा है? Towards this oxygen. So electron density around the oxygen atom here increases, which makes the bond more polar. Okay, and you know very well, if the bond is more polar, then it is very easy to break the bond. Okay, and the carbocation here, because here when the carbocation is formed, when this OH is removed, the carbocation is formed. So this carbocation, three tertiary carbocation is more stable. Why it is more stable? Because in the carbocation has 3 plus I group. Okay, so the 3 plus I group, it just pushes the electron density towards this adjacent carbon, and due to that, the electron density of the oxygen, it increases, which makes the bond more polar, and the carbocation which is formed is more stable. Got my point?
Yes, ma'am.
Yes, ma'am.
So, so that's why when the number of alkyl group increases, the plus I effect increases. And if plus I effect increases, it increases the electron density of the carbon. Okay, and it makes the bond more polar, and due to that, the carbocation which is formed is more stable. So that's why 3-degree carbocation is more stable than 2-degree, than 1-degree, than methanol. Okay, so that's the order of reactivity of carbocation. And you know the reason, was the reason behind that. So reaction with hydrogen halide. The reaction with hydrogen halide. Okay, so alcohols react with hydrogen halide to form alkyl haloalkene. Okay, I think we have discussed this in the previous chapter, haloalkane and haloarenes. Okay, the reaction of the basically the formation of methods of preparation of haloalkanes from the alcohol. उसमें हमने discuss किया था, right? So the reaction of hydrogen halide. So when alcohols react with HX, halogen acid. Okay, this is a halogen acid or halogen halide भी कह सकते हो आप. Okay, so what happens from here? What you are supposed to do again? Dehydration karana. This H2O, OH from the alcohol and H from the halogen acid, right? Hydrogen acid. So it will combine and they will dehydrate. यहाँ पे water remove करा देना and the haloalkane will be formed. RX. RX will be formed. Alkyl halide or haloalkane, you can say. So that's the reaction. And you know very well, the reactivity of halogen acid is HI, then HBr, then HCl. HI, then HBr, then HCl. We have already discussed in the haloalkane and haloarene chapter. Okay, and the reactivity of alcohol is 3-degree, then 2-degree, then 1-degree, then methanol. Okay, so remarks is due to lower reactivity of HCl with primary and secondary alcohol, we use anhydrous. Yeah, this is again very important. This is again very important. So due to lower reactivity of HCl, HCl is less reactive among the other halogen acid. Like HI is most reactive. After the HI, it's HBr, then HCl. HCl is less reactive, okay, towards primary or secondary alcohol. So what happens? We use, due to the lower reactivity, so we use anhydrous ZnCl2 as a catalyst with HCl. Okay, so and this two combination, anhydrous ZnCl2 plus HCl, they are known as Leucas reagent. What is Leucas reagent? HCl plus anhydrous ZnCl2 is known as Leucas reagent. Okay, and this Leucas reagent is used in the distinction test of primary, secondary, and tertiary alcohol. Okay, this is very important. So Leucas test में हम इसे use करते हैं this HCl plus the anhydrous ZnCl2 to distinct to distinguish between the primary, secondary, and tertiary alcohol. Suppose we don't know which type of alcohol it is, like primary has secondary and tertiary. How you will distinguish between which one is primary, secondary, or tertiary? So we just do this test, Leucas test, and in this we use this reagent. Leucas reagent means HCl plus anhydrous ZnCl. Okay, so when alcohol when you treat it with Leucas reagent, so okay, so it will give you RCl. It will form RCl. Okay, your R alkyl chloride. Okay, your alkyl chloride. And alkyl chloride is white in color. Basically, you will get a white PPT in your test tube. Okay, suppose you just take unknown, you don't know what is the which type of alcohol it is. So when you take the alcohol, okay, like 5 ml or something, and when you add HCl plus ZnCl to Lucas reagent, so if there is no turbidity, when you add the Lucas reagent, if there is no turbidity at the room temperature, अभी room temperature की बात हो रही है, okay? So if there is, if on room temperature, if you don't see the turbidity, okay, so just it is a primary alcohol. It's a primary alcohol because primary alcohol does not react with Lucas reagent at room temperature. At room temperature. So that's how you can distinguish between the primary and the other one, right? So if the alcohol, if the unknown alcohol does not give the test, okay, does not give the white PPT or turbidity, okay, or at room temperature, so it is a primary alcohol. But once you give the external temperature, external energy, okay, so after some time you will see the turbidity in the primary alcohol also. But we are talking about the room temperature. So at room temperature, there will be no reaction in primary alcohol. So primary alcohol give a negative test, negative Lucas test. Clear?
Yes, ma'am.
And the secondary alcohol. So secondary alcohol, when you when you add the Lucas reagent, so you will see the turbidity, but after some time, like after 5 to 10 minutes, when you wait for the 5 to 10 minutes, after that you will see that turbidity is coming. Okay, so it's a secondary alcohol. If the turbidity, again, we are talking about the room temperature. At room temperature, when the secondary alcohol gave the test, but after some time, like 5 to 10 minutes, बाद turbidity आती है. After 5 to 10 minutes, after 5 to 10 minutes, the RCl is formed. And you know what is the color of RCl? So it's white color. White color PPT you will see and turbidity as a turbidity. But what about the tertiary alcohol? So tertiary, you know very well, tertiary alcohol are most reactive, right? You can see the reactivity order. You can see that reactivity order, tertiary alcohol is more reactive. So that's why when you put the Lucas reagent, so immediately it will give the test. It will give the turbidity. Okay, so tertiary alcohol. So इससे हमें ये भी पता चलता है कि tertiary alcohol is most reactive. Okay, after that, secondary alcohol, then your primary alcohol. So this test is basically used to distinguish between primary, secondary, or tertiary. Now the question is, which type of question can come from this topic? So they will give you two alcohols like pentane 1-ol or pentane 2-ol. Okay, and they will tell you how you will distinguish between pentane 1-ol and pentane 2-ol. Okay, so pentane 1-ol, you know, it's a primary alcohol, pentane 2-ol, it's a secondary alcohol. So again, you can distinguish. You can write down the reaction, this reaction, alcohol plus Lucas reagent. So it will give you this test plus water. Okay, but primary alcohol, pentane, आप show कर दोगे, pentane का structure बना दोगे, pentane 1-ol का. And when you put the Lucas reagent, means HCl plus anhydrous ZnCl2, so there will be no reaction at room temperature. It's important to mention the room temperature here, right? But secondary alcohol like pentane 2-ol, when it will give the positive test and it will give a turbidity after 5 to 10 minutes. So it confirms that this is a secondary alcohol and this is a primary alcohol. Okay, so you can distinguish the pentane 1-ol and pentane 2-ol by Lucas test. Okay, so Lucas test, the primary alcohol will give the positive, will give the negative Lucas test. Okay, at room temperature, but secondary alcohol will give positive Lucas test, but at after 5 to 10 minutes. Clear? Yeah, see this type of question. How you will distinguish between propane 1-ol and propane 2-ol. Okay, so that's how you have to write down in your exam. So you have to draw this structure. This is the pentane propane 1-ol 1 2 3. Okay, propane 1-ol. When you add the Leucas reagent, and if possible, you can write HCl plus. Don't write Leucas reagent. Just write HCl plus your anhydrous ZnCl. Okay, these two reagents, the combination of these two. So there will be no reaction at room temperature. Okay, but white turbidity will be there on heating. Okay, so that's the primary alcohol. And secondary, this propane 2-ol, this is a secondary alcohol, but how you will distinguish it between these two alcohol by using test. So when you add the Lucas reagent, so it will give white turbidity after 5 to 10 minutes. Okay, so you can distinguish these between these two by Lucas test. Okay, so that's how you will write down in your exam. The propane 1-ol gives white turbidity on heating when treated with Lucas reagent, but propane 2-ol gives white turbidity with Lucas reagent after 5 to 10 minutes. Got my point?
Yes, ma'am.
Okay. Next one. Yeah, see the mechanism.
Can you scroll up?
I will share the notes with you after this class. Okay, no
Alright.
problem, you can write. Because we have to complete this chapter as okay. So mechanism. I will share the notes, okay? After this class. Just a second. I don't know why it's not working today. Okay, let's understand the mechanism of this. So primary alcohol reacts with HX, means halogen acid, via SN2 mechanism, right? So SN2 mechanism यहाँ पे show होता है like when see suppose first step, you know very well it's a first one step mechanism, but I have written it here in the three steps to make it very clear step by step. So first this HX is there, hydrogen acid. Okay, halogen acid, right? It's a halogen acid or hydrogen chloride, hydrogen halide, you can say. HX is the hydrogen halide. So in the when it dissociate, it will form H plus and X minus, right? H plus and X minus because X is the most electronegative, so it will acquire partial negative charge, and this hydrogen will acquire positive charge. Now, in the next step, when alcohol, this R, suppose this R CH2OH. Okay, so alcohol plus H plus. So what happens? This oxygen has a lone pair, so it will approach this H plus ion. ये क्या करेगा oxygen, the lone pair of the oxygen, it will try to approach this H plus ion, and what happens यहाँ पे H plus OH2, H was there and another H plus came and joined the oxygen, so it will have a positive charge, okay? Because oxygen can make two bonds, but here the three bonds are there, so positive charge over here. Now this is very unstable. This is very unstable. So what happens from here? The water will be liberated out. This is very unstable. OH2. So OH2 is nothing but a water. So यहाँ से ये bond will be break, and in the next step I have showed here, what happens, this bond will be break and this water will be liberate out. Okay, and when water will be liberate out, so on this carbon there will be a positive charge, there will be a positive charge, right? So if there is a positive charge, so what happens, this nucleophile will come, X minus is a nucleophile here, so nucleophile will come and try to approach this carbon, positive carbon. Okay, and here the bond will be formed between R and X, and it will give you a halogen. Okay, your haloalkane over here plus water. That's the mechanism how the primary alcohol reacts with H, halogen. Is it clear?
Yes, ma'am.
Okay, see the mechanism is very simple. What you're supposed to do, you know very well. HX किसमें ionized होगा? H plus and X minus. And what is X minus? Nucleophile क्या होता है? It's a negatively charged, electron rich होता है, right? So this is the nucleophile over here. So what happens when alcohol, this is the primary alcohol, right? So it has oxygen, has a lone pair. So everything is up to this oxygen. This oxygen will try to approach this H plus ion, right? Because it's a negatively charged. So obviously in the chemistry, just just remember this trick. Always the negative will comes to the positive. Positive will हमेशा क्या होगा? Unlike will attract each other. Unlike charges attract each other, right? So how you will write down the mechanism. This negatively charged lone pair, it will try to approach this H plus. So H plus यहाँ पे आ जाएगा, and you can see this is unstable. Why? Because oxygen can only make two bonds. Okay, but this is a three bond, so this is very unstable. So what happens? This bond will be break from here, and the hydrogen water will be liberate out. So when water will be liberate out, so here the on this carbon there will be positive charge. And if it is a positively charged, so you know nucleophile is electron rich. तो किससे attract करेगा? Where the electron is less, right? So here the positive charge means this carbon has a deficiency of electron. Electron की कमी है, so this negative charge nucleophile will come and attach on this carbon, and it will form haloalkane will be formed, right? So that's the mechanism. Next, yeah, this is all about the primary alcohol, but secondary alcohol react with HX via SN1 reaction, SN1 mechanism. And what is SN1 mechanism? It's a two-step mechanism, right? Means the formation of carbocation and then attack of nucleophile, two-step mechanism. So secondary alcohol reacts with HX via SN1. Now let's do the mechanism. Try to solve this question. Okay, so you can see this is a secondary alcohol, right? So how you will, so what will be the product? Yes, Muniba, tell me what will be the product here? We have already discussed in the previous chapter. See, what happens? H plus and Br minus. Okay, now what happens? This OH is a good good living group. So what happens? It will left the group and the bromine will come and attach on this carbon. So what will be the product? This bromine. This bromine. Is this a product? Yes or no? Yes or no? Is this a product? See, in the previous, see, when the SN2 reaction, when you see the SN2 reaction mechanism, what you're supposed to do, the OH is removed and X is being, OH is being replaced by the X halogen atom, and you will get this product. So similarly, in this case, the OH will be replaced by this bromine. But no, this is not your product. Why this is not your product? Because you know very well the secondary, this is your yeah, what happens in this case, it will form, you know very well, because tertiary carboxyl is more stable than the secondary than primary, right? So but here what happens, यहाँ पे secondary carbocation बना होगा, but secondary carbocation is not as stable than the tertiary one, so it will try to rearrange itself, or it will try to, this bromine will try to shift its position. So here you will see the 1,2 hydride shift. 1,2 hydride shift. I have discussed this in the halogen, the previous chapter. Right? 1,2 hydride shift or 1,2 methyl shift. Both conditions I have discussed. Just a second. Okay, let's see. So here in this case, this will be not your reaction. This is not your product. So instead of this, क्या बनता है product? This methyl group. And on this carbon, the bromine will be attached. Okay, now let's see the mechanism. Why on this carbon, the bromine is attached instead of this? Because it's following the SN1 reaction, right? So you should make this product, not this one. So why this bromine tertiary halide is formed? Tertiary alkyl halide is formed. So see, write on the mechanism. Okay, see the mechanism. This was the OH. This is the CH3. Okay, so what happens here? This is again in the H plus and Br minus. So first step again will be your H plus, right? So this oxygen has a lone pair, so it will try to approach this hydrogen, right? It will try to approach this hydrogen, and what happens here? OH2 and plus will be formed, which is very unstable. Which is very unstable. So what happens? This bond will be break, and यहाँ से क्या हो जाएगा? Dehydration will occur. Dehydration will occur. Now, what happens when the dehydration will occur? So here the formation of carbocation. So when this bond will be removed, so इस carbon पे क्या बनेगा? Carbocation. Cation will be formed. Okay, and this CH3 as it is, and here one hydrogen is present. Okay, one hydrogen is present. Now, you know very well, this is a secondary carbocation. Okay, this carbocation has a two groups, so this is a secondary carbocation. But secondary carbocations is other stable kya hota hai? Tertiary, and it has an option. It has an option. It can make it can shift its hydrogen. ये क्या करेगा? This carbocation will this hydrogen. See, this is the adjacent carbon. This is a carbocation here, and this is the adjacent carbon. So what he tries to do, this hydrogen will shift from here. This hydrogen will shift from this. Suppose this is the first position and this is the second position. So what happens? There you will see the hydride shift. 1,2 hydride shift. Hydrogen from here, this hydrogen bond from here will shift from first position to the second position. Okay, to the second position. So this is your 1,2 hydride shift. This is your 1,2 hydride shift, and it will form, basically this hydrogen will shift here, okay, and this carbocation will shift over here on the second position, okay, and CH3 as it is. Now see, this forms a tertiary carbocation. This forms the tertiary carbocation, and you know, because everyone here in this world and in this chemistry world, everyone is moving towards stability. Everyone wants to be more stable. So this secondary carbocation was a stable, but not as compared to the tertiary one. But it has an option. It can shift its this hydride. Okay, basically it's a shift करेगा 1,2 hydride shift, and it forms a tertiary carbocation, and this is more stable, right? This tertiary carbocation is more stable. This is the hydrogen. Now what happens next? Now the carbocation has been formed. Okay, what is the second step? First step will be the SN1 reaction. The first step क्या होता है? Formation of carbocation, and the second step is your attack of nucleophile. And what is the nucleophile over here? Bromine minus, Br minus, right? So Br minus will come and attach in this carbocation. So that's how CH3, and here bromine, and here this is the hydrogen CH2. So that is the product. Okay, that's how this tertiary alkyl halide is formed, not the secondary one. Is it clear, everyone?
Yes, ma'am.
And please, after the class, practice these mechanisms by yourself. Okay, then only it will be more clear. When you practice much, when you write by your own, when you practice it by your own, so it will be more clear. Okay, step by step, just try to do the things. It is very easy. First step में this lone pair of the oxygen, it try to approach this hydrogen. Okay, when it try to approach this hydrogen, here OH2 plus, and this OH2 plus is very unstable. So यहाँ से क्या होगा? Water will be removed, and if water will be removed, so here the formation of carbocation will be there. यहाँ पे carbocation form हो जाएगा, right? Now this is a secondary carbocation. Now secondary carbocation is not as stable as tertiary one, so it just try to become more stable. Okay, so what it does, so here 1,2 hydride shift hoga. This one position, this is one position, and this is second position. So first position has a hydrogen, and then the second position there is a carbocation. So यहाँ पे exchange हो जाएगा 1,2 hydride shift. So hydrogen shifts from the first position to the second, and this carbocation shifts from the second to the first position. So that's how tertiary carbocation is formed. And now in the second step, bromine minus, which is the nucleophile, it comes and attacks the carbocation, and it forms this product. Okay.
Yes, ma'am.
Next one. Reaction with phosphorus halide. Now you guys will tell me this reaction, because already we have covered this in the methods of preparation of alkyl halides. Okay, the same reaction we are discussing here in the chemical properties of alcohol. But in the haloalkane chapter, we will discuss this in the method of preparation of haloalkane. Now tell me, reaction with phosphorus halide, right? So we will use different phosphorus halide as a reagent, and we will treat it as we treat it with the alcohol. So what will be the product in this case? So first, yes, Muniba, tell me, when alcohol ROH, when it is treated with PCl3, so what will be the product? Yes, with PCl3, what will be the product? Afrina, Jovita, anyone? Very simple. ROH? Yes, Afrina?
Here.
Yes, RCl. So OH will be replaced by chlorine and you will get RCl. As I told you, we have discussed it in the methods of preparation of haloalkane. The method of preparation of haloalkane vaporite means the haloalkane will be formed, right? So when alcohol is treated with PCl3, haloalkane will be formed, which is RCl. So OH will be replaced by chlorine. Similarly, second one, so when ROH is treated with PBr3, so here RBr is formed. Okay, right phosphorus plus X2 and X2 could be your either iodine or bromine. Okay, so here again RX will be formed. And in this case, when PCl5 के साथ react करोगे तो OH will be replaced by again C. These are the products. Okay, I will not discuss it in details because I have already done. Okay, so these three. Yes, Jupiter, tell me what will be the first product? Jupiter, first product CH3, CH2OH when it is treated with PCl3.
RCl plus
Yes, instead, C on the place of OH will be Cl, right?
Cl.
Yeah. Second one, in the place of OH, you have to attach bromine. Okay, in the place of OH, you will attach I2 over
I.
here. Not I2, only I. Okay.
I.
Similarly, third reaction, again we have already done reaction with thionyl chloride,
R
SOCl2. Yes, again you will get RCl plus, in this case you will get SO2 plus,
plus 16.
yes, very good. All both these are SO2 and HCl are in the gaseous form, so you will get this RCl in the purest form. So no need for further purification. That's why this reaction, this method of preparation of haloalkane is preferred. Okay, why it is preferred? Because in this the byproduct is SOCl2, sorry, SO2 and HCl, which is escapable gases. Okay, and we get a pure form of your alkyl chloride. So there is no need of purification. Okay, so what is the example? So this is your example, CH3, CH2, CH2OH. Okay, propanol when it treats with SOCl2. So what will be the product? You will get propyl chloride. 1, 2, 3, and here chlorine. Okay, so on the place of OH, so OH is replaced by your chlorine. Yeah, I've already discussed this. Why thionyl chloride is preferred. Okay, fourth reaction. This is again very important. I I just I just see this many times, like write down the mechanism of acid dehydration. Okay, and they just give you the reaction and they just ask you write down the mechanism of this reaction. So this is very important. Okay, repeated questions है ये previous year questions में मैंने देखा है. right? So acid dehydration reaction is very important. So let's see, let's understand one step by step. So what is acid dehydration? Acid dehydration means in the presence of acid, what happens? Dehydration occurs. Water will be removed out. Okay, dehydration means water is removed out in the presence of acid. So what happens in this reaction? So alcohols with at least, what is the condition? Let's see. What is the condition for this reaction? So alcohol with at least one alpha hydrogen. अल्कोहल जिसके पास एटलीस्ट एक अल्फा हाइड्रोजन होना चाहिए. This is the condition for this reaction, right? So this is the OH. OH is attached to this carbon. So this is the alpha carbon. This is the alpha carbon, and this alpha carbon के पास जितने हाइड्रोजन present है, suppose this is a one hydrogen is present. So this is the alpha hydrogen. Okay. So the hydrogen which is attached to the alpha carbon is known as alpha hydrogen. Okay. And what is this? This is your beta. This is your beta position, which is adjacent to the alpha carbon. Okay, so what is alpha carbon? The hydroxyl group. The carbon to which the hydroxyl group is attached is alpha carbon, and the hydrogen which is attached to the alpha carbon is known as your alpha hydrogen. Okay, and this is your beta carbon. Now, what you are supposed to do when alcohol, which is having at least one alpha carbon, reacts with protic acid. Now, what is protic acid? Protic acid are those which has a proton, like H plus hone chahiye. Like your H2SO4, HCl, H3PO4. These are some protic acid which has a protons, right? So when they are with in the presence of a protic acid like your sulfuric acid, phosphorus acid, so they will form alkene. Why they will form alkene? Why? Because due to the beta elimination reaction. So what happens here? Here beta elimination reaction ho jata hai. What you are supposed to do? OH. See this. See the mechanism here. Just a second. Yeah. What you are supposed to do in the beta elimination reaction, basically this is a acid dehydration. So apne, at last you have to dehydrate. Basically you have to remove water from this alcohol. So OH you will remove from the alpha carbon. From the alpha carbon, you will remove the OH group, and from the beta carbon, you will remove one hydrogen. Okay, so they will combine and they will liberate as a water H2. So when these two bond basically remove, what happens? यहाँ पे क्या आ जाएगा? Double bond. There will be double bond between these two carbons. So this is the alkene. Okay, so that's how alkene is formed via beta elimination when the alcohols with at least one alpha hydrogen react with the acid. Okay, which type of acid? Which has a protons, protic acid. Okay, so which groups are removed? OH group is removed from the alpha carbon, and hydrogen is removed from the beta carbon. Okay, so that's why it is known as beta elimination reaction. From the beta position, you are eliminating the hydrogen. Okay, and from the alpha, you are eliminating the OH. Got my point?
Yes, ma'am.
Okay, so just remember this COH, which bond will be break and which bond is formed. So COH, this COH bond will be break. Okay, and this CH bond will be break. These two bond will be break, and new bond will be formed between the carbon and carbon, and between the carbon and carbon, you will form the pi bond. Okay, you will form the pi bond forms. So pi bond is formed, so it's a alkene. Basically, alkene is. Now let's see the mechanism, because the mechanism is very important. Okay. So yeah, direct question. This type of question can come. They will give you the reaction. The CH3 alcohols they denge, any acid which has a proton and heat, okay, some temperature, and they will give you, they form alkene. Okay, whole reaction they will give, and they will ask you write on the mechanism. What is the mechanism of this reaction? Okay, so let's see. Step one. So this alcohol, which has a, you have to check first this alcohol has a alpha hydrogen or not. So you can see this OH group is attached to this carbon. So this is the alpha carbon, and this carbon has two hydrogen. Yes. Yes, the condition is fulfilled here because we need only at least one hydrogen, at least one alpha hydrogen, but they are two alpha hydrogen, right? And in the presence of acid, H2SO4, what happens? What will happen? The dehydration आपने करा. Okay, how you will do the dehydration? OH, the OH group will be removed from the alpha position. Alpha carbon से आपने क्या remove करना है? OH. Okay, and from this is a beta carbon. So from beta carbon, you have to remove one hydrogen. Okay, you have to remove one hydrogen from the beta and the OH group from the alpha carbon. So that's how you will get the alkene. Okay, so first step, the protonation of alcohol. First step will be the protonation of alcohol. So let's see the step. This is your CH3, CH2, and OH. Okay, this was the alcohol. Okay, ethanol liya हमने. And you know very well this oxygen has a two lone pair, right? And this is a protic acid. H2SO4 is a protic acid. So it will give you a proton, H plus ion, right? So what happens? You have to do the protonation. अब यहाँ पे क्या हो जाएगा? Alcohol का protonation हो जाएगा. Because this oxygen has a lone pair, so it will approach this hydrogen. Okay, and the protonation of alcohol, CH3, CH2, and here O and two hydrogen. Okay, one hydrogen is approach किया, and there will be positive charge over. And you know this is very unstable, right? This is very unstable. So यहाँ से क्या होगा? Dehydration will occur. Hydrogen H2O will be removed, and यहाँ पे this carbon will have the positive charge. Means the formation of carbocation. Okay, so first step will be the protonation of alcohol. First step क्या करोगे? Protonation करवा दो alcohol का, right? Second step will be the formation of carbocation. Okay, so how the formation of carbocation will be there? CH3, this is a CH3, CH2, oxygen, two hydrogen. This has a positive charge. Now see, because this is very unstable, what will happen? This bond will break. Okay, and due to this, there will be a formation of carbon. CH3 and here CH2. This is CH2 and 1 plus charge. Right. So this is a formation of carbocation because this H2O, this is very unstable. So यहाँ पे water will be removed out. Water will be removed out and here the formation of carbocation. Okay. Second step, third step. Third step will be the removal of H from the beta carbon. So this is your alpha carbon, right? So this is your alpha carbon. This is your beta carbon. So third step will be you have to remove one hydrogen from the beta carbon. Okay. So suppose this is your CH3. This is your CH3 and this is your CH2 and CH2 will have the positive charge. Carbocation is there, right? Now what happens? You have to shift one bond. You have to remove this one hydrogen from here. Okay, removal of hydrogen from the beta carbon. This is the alpha carbon, this is the beta carbon. You have to shift this bond here. Okay, so what happens? What happens? CH2. Okay, two hydrogen of this carbon and here the double bond in CH. Now see the bond is with this carbon has four bond. Okay, because this four carbon is tetravalent, so 1, 2, 3, 4. 1, 2, 3, 4. Now it's satisfied plus H plus will be removed. Okay, so these are the three steps of this. Yeah. So these are the three steps, three mechanisms. So basically, acid dehydrogenation occurs via three steps. First step will be the protonation of alcohol. Second step, formation of carbocation. And the third step will be the removal of hydrogen from the beta carbon. Any doubt in any step?
No, ma'am.
Are you sure? Because this is very important. If there is any doubt, just please clear your doubt now. Clear to everyone? Okay. Okay, so I stop it here. Okay, after I stop it here, then after this, there are some remarks and there, yeah, other reactions are also there, which we will discuss in the next class. If there is any doubt, you can ask Vichu.